Lerping values is an essential skill for all game developers, whether you are lerping position, scale, rotation, alpha, color, or any other number of options. And if you've been into game development as long as I have, then you've probably written hundreds of coroutines. And they work just fine, but they are a pain to write, and it is a lot of code for such a tiny little task. So I started creating my own system to deal with all of this stuff, and I didn't really realize it at the time or plan on it. What I ended up doing was creating my own tweening library. And by the way, there are many, many tested, awesome tweening libraries out there that are free, but I can sometimes get a little bit frustrated with those as well because they can feel a little bit bloated at times. So stick around and follow along if you want a very simple but very extendable custom tweening library that you made so you don't need to get stuck reading other people's documentation or Googling how to do even the most simple things. Ready? Let's go. So we're going to start off by making a new script called iTween. This is just going to be a really simple interface with a few methods and properties that we'll end up implementing later in our tween class. This interface is not strictly necessary, but it is a big part of keeping this system extendable. You may end up wanting to create different types of tween classes, and having them all implement this interface would mean that we could keep a list of all of our tweens by having a list of iTween, rather than search for a bunch of different tween classes. All right, so we'll create two more classes. One is going to be called Tween, and the other will be our Tween Manager. And let's open up our Tween class. So this is not a mono behavior. It's just going to implement iTween. So this doesn't need to live in our scene anywhere. And let's go ahead and implement those interfaces. Right click, Quick Actions and Refactoring, Implement Interface. Now, this update method here is not to be confused with mono behaviors update. This is not going to run automatically because, again, we're not inheriting from mono behavior, which is where update comes from. So this will need to be manually called from somewhere. And we'll end up doing that later in our Tween Manager class. Now, besides the interface, the other special thing about this class is that we want to be able to tween any value. It could be a float, it could be a vector3, it could be a color, any type that is lerpable, basically. So we are going to make our tween generic by passing in t like this. T is just the standard way of writing something that is generic. Whether you're familiar with making generics or not, you use generics all of the time when you call getComponent, for example. It doesn't know what type is going to be returned, so they make it generic. Now, making this class generic, what this is going to allow us to do is to create our start value and end value, both with type t. Again, they could be anything, we don't know yet, so we use a generic and pass in the type when we actually create a tween. We're also going to want a duration, which is just seconds, so that's always going to be a float. And let's pass in an action of type t as well, since that's the event that we're actually going to call every frame to lerp the generic value between the start and end value. And we're going to need a timer as well. Okay, so before we do our update method, we need a constructor. You can actually just right-click a class, Quick Actions and Refactoring, and generate a constructor that way. But you can see it's just a method with the same name as our class. There's nothing special about constructors. You can kind of think of a constructor like an awake method in a monobehavior class. As soon as an instance of this tween class is created in the game, which you do with the new keyword in a non-monobehavior class, the constructor gets called once, just like awake. And that is really useful to pass in certain values that we need to set, like the object we're targeting, the property name, the start and end value, the duration, and what actually happens on the update of the tween. So for each of these parameters, we have a property equivalent. So we'll make all of them equal the parameter that we pass in. So now that we have a constructor, we will be forced to pass in all these values whenever we create a tween. You'll see that in action soon enough. Now, one more method. Probably the most important one that we need in this class is our interpolate method. We eventually need to translate our generic types that we're passing in back into what their actual types are going to be and lerp them. So this method is going to do that. And we'll do that by checking is start a float and is end a float. You'll notice after I'm checking is start a float, I'm also creating a new local variable called start float here. Start is generic, but start float, you can see, is an actual float type, which we will need for our mathf.lerp function. And by the way, very, very important for floats especially, use lerp unclamped for a tween library. We will be implementing easing functions soon, and some of those overshoot their target position, which will not work if we're just using regular mathf.lerp because that clamps the value, okay? And now we do need to cast this float back to a generic type because we're returning a generic type with this method. And as I understand it, we can do that by casting t through type object like that. And we'll also just throw a message if we're trying to return another type that we haven't implemented yet. Quick note, by the way, you'll notice I'm not using unclamped for color because colors can get a little bit weird when they're overshot. So we're going to keep these clamped. Okay, now let's do the update function. It's going to be pretty simple right now. If it's complete, we return. We increment our timer, turn that into a %, feed that into our interpolate method, which is really just a lerp function. Invoke our onTween update. This question mark here is just shorthand for a null check. And we pass in the current value that's being interpolated. And if the elapsed time is greater than or equal to our duration, then it's complete. So let's get the very basics working first, and then we'll come back and add in all the really cool stuff. This is just currently a super basic linear interpolation. But for now, to get things working quickly, let's just pass in a default value here so that it doesn't give us any errors. And let's open up our Tween manager. And design-wise, I want this to be absolutely as easy as possible for us later on down the line. So we're going to make this a singleton, and if there's currently no Tween manager in the scene, then we'll just go ahead and create one. Now, as I said, we are going to make a list of all the tweens and loop through them and update them, but it's not going to be a list actually, it's going to be a dictionary. If you are not familiar with dictionaries, they work very similarly to lists, except you pass in two things. You pass in the actual type that you want the list to be made of, in this case, iTween. But the first thing you enter is a key, or as I like to think of it, a unique identifier, something that you can use to search for a particular index in your dictionary list. And if you recall, in our tween constructor, we passed in a string called identifier. So our first type in the dictionary will be a string, meaning we can look up any tween in the dictionary using our identifier string and then do something with it. Now, first, we need to get these tweens added to our dictionary when they're created. So let's create a helper method for that. And you can add something to a dictionary like this. And where we'll call that actually is going to be right here in our tween constructor. So as soon as it is created, it gets added to the dictionary. Now, in our update function in the tween manager, we'll say for each pair in our active tweens. I'm using var, by the way, because it's a lot shorter and easier to read than this, which is what it actually is. Okay, now we'll get a reference to the tween by grabbing the pair's value, and then we'll call update on it. Okay, so our tweens are being updated. Now it is time to make our helper methods. These are the methods that we're actually going to end up calling when we want to tween some value in the first place. So as we run through this, I will create a few different examples. Now, what I love about this is you can stay pretty high level and vague, which we'll do in a little bit, or you can get really specific and make as little work for yourself as possible later on down the line. You'll just have to create more helper methods if you do it that way. So let's say I want to make this as easy as humanly possible for myself, and so we'll create a method specifically for tweening a sprite's alpha. So we'll make a static method, and we'll pass in, we could do a sprite renderer so that we could pass in like a cached reference from wherever we call it, or we could just pass in a game object and grab the sprite renderer on the fly like this. This way is just a teensy bit slower, but it is easier for us down the line, so you can do this however you want to do this. And now we need to think, how many parameters do we want to put in? Well, let's directly state our start and end alpha, as well as how long it should take. Now is where we actually create a new instance of our tween. So we say new tween, and like I said, we need to pass in all of the parameters from our constructor. So the target is going to be our game object. And now we need a string for our identifier. And this will make sense why we're doing this a little bit later, but for now, we're just going to create one here like this based on the instance ID of the sprite renderer, and also add alpha at the end so that we know exactly what's being modified, as well as the start and end alpha, the duration. And for the action, you could create a separate method and just plug that in here, but it is easier to use a Lambda expression and just create the method right here, right now, that way. And remember, this is the onTween update action. So this thing gets called every frame here. So what are we doing every single frame with this tween? We are updating the sprite's alpha. So to do that, we get a reference to our sprite color, change that color's alpha to equal our value from the action, and then assign that color back to the sprite renderer's color. Colors are a bit annoying because they are structs, so we can't just change sprite renderer.color.a directly. Unfortunately, you have to create a new struct, change one of its values, and then assign that struct to whatever you want to change. And then at the end, we return the tween. And we want to return the tween for two really, really important reasons. One of them is just being that you can create a variable of type tween when you actually call this method in case we want to pause it or anything like that. But there is a second reason, which is so cool and I can't wait to show you, and you're going to see it really, really soon. So let's create a little test just to make sure that our basics are working here. So I have this little square here with a test script on it. And in there, I'm just checking for space with my keyboard. And if that's true, then let's call tweenManager.tweenSpriteAlpha. We'll pass in this game object, start at 1, go to 0, and do it in 0.75 seconds. And that's it. And you can see it's working. It goes from full alpha to totally transparent in just under a second. And it is cool because now every single time we want to do that anywhere in our game, we can just call this method. It's really easy. That is cool. But there is so much more that we can do with this. And it's really not that hard to add in all of that extra functionality at this point. So let's start with the obvious one. One of the greatest things about tween libraries are the built-in easing functions, and there are quite a few of them. Now, you can find these all over the internet. I actually just went to ChatGPT and asked it to generate me a list, and it gave me this giant enum here, which I put outside of the class, by the way, to make it nice and easy to call. After that, I asked it to spit out all of the equations as static float methods with float t as the parameter, since our tween is going to handle all of the rest of the parameters. And it just gave me all of these. And then I turned that into a function called ease, which takes in our ease type and our float t, and just does a massive switch statement to choose the correct equation based on whatever enum we plug in here. Now, this was all in the name of making it easier down the line to call the ease function. Now, once you've done all of that, let's create a new variable up here and default it to linear so that if we choose no ease type, it's just going to do a normal linear interpolation. Now, to actually use all of those easing equations, we just create one line here. We'll call it eased t and call our ease function, passing in our ease type and t. And now over here, instead of passing in t, we'll pass in eased t instead. So the last question is, how do we actually pass in which ease function we want to use when we call this method? And we've got some options. We could certainly pass it into the constructor as a parameter and give it a default so that we're not necessarily forced to pick one when we create the constructor. However, I have about 6 other extensions that I want to add to this to make it even more awesome. And doing it that way will start to make our function really, really long and take away from that easiness that we're really going for here. So what we are going to do is give ourselves the option to create method chains. And if you don't know what that is, you are going to love it, I promise you. So what we're going to do is down here, we'll create a public tween method called setEase, passing in the ease type. And we'll just say that this class's ease type is the ease type that we pass in when we first call this method. And then, very important for method chaining, return this. Okay, so what the heck did we actually just do? Well, let's create a better example that will showcase it a little better than Alpha will. So I'm going to create another helper method in the tween manager here, this time for our scale. So this one's going to return a vector 3. So we'll create another identifier, grab the transform, and create a new tween, passing in all of our parameters and using a lambda expression to change our transform.local scale to the value and then return the tween. Okay, now back in our test script, let's call that new tween scale method we just made. And just say our new scale will be vector3.1 times 1.25. So right now, this is just going to do it normally, right? It'll do it linearly. But if we want to add easing, we can just say dot set ease type, and let's choose elastic ease out. Okay, that is method chaining. You can also press enter here and enter a new line down here to keep it nice and clean, because we are going to be adding 6 more of these. You can call them all in exactly the same way. Now you can see we press space and it kind of bounces to that new scale amount. That is the easing at work, okay, which is so cool. Now, I don't want this video to be hours long, so we're going to add 6 more extensions that you can add via method chaining, which I'm sure you can imagine is far more powerful than just a coroutine that does exactly what you want and nothing more. So we need to add some variables at the top of our class to track all of that stuff. Now down here for the chaining methods, we'll create a set ping pong. Set on complete. Set ignore timescale. Set on update. Set on percent completed. And set start delay. And now in our actual update method, we need to implement the logic for all of those. So for the ping pong, we'll say if reverse, then we'll go from end to start. Otherwise, do what we had there before. And then in here, we'll iterate the loops completed, reset our elapsed time. And if ping pong is true, then we'll change the reverse flag each time a new loop happens. Then if our loop count is greater than 0 and our completed loops are greater than or equal to our loop count, then the tween is complete. Now for on complete, we have to be careful with the timing of everything because we will be removing things from our dictionary of tweens soon. And if you remove array, list, or dictionary items while iterating through them, you can cause errors. So for that reason, we're actually going to invoke our on complete action in the tween manager in update if the tween is complete and if it's not null. We'll also null it out afterwards. For ignore timescale, back in our tween in the update, we'll say if ignore timescale, we'll iterate our elapsed time by time.unscaled delta time. Otherwise, just do normal delta time. On update is easy. We'll just invoke it if it's not null. For on percent threshold, and by the way, this is why making your own is so cool. I've always wanted this callback baked into a tween library, but I've actually never seen it before. So we'll check if our threshold is greater than 0 and if t is greater than or equal to that threshold. If that's true, then we'll invoke it. And we're checking for 0 or greater because here we'll reset it back to -1 so that it doesn't get called every single frame. And for the delay, we'll check up here for ignore timescale again and iterate our delay timer based on whether or not that's true. And then if that timer is greater than or equal to our delay time, then we'll run everything else inside of that. So nothing runs until that is true. Okay, so now we have all of these different method chain extensions that we can call on our tween. If you want it to loop forever, set ping pong to -1. If you want to invoke a method 50% of the way through your tween, type in 0.5 and the function you want to call at that point. So actually just a few more methods and this tween script is all done. Let's fill in pause and resume. Now in update again, just wrap the entire thing inside an if is paused is false. Now we need to kill the tween when it's done as well. So we actually have two methods for that. On complete kill is specifically for when the tween completes and it's finished. So we'll call that here in update. We also will call this back in tween manager in the add tween if we already have an item in our dictionary with that same identifier. If we do, that likely means we're trying to modify the same property on the same game object as another tween, which can cause some really weird behavior. So we'll kill the current one and add the new one. The full kill method will kill the tween if the object that this tween is referencing gets destroyed. Like say you're trying to tween the scale of an enemy, but you just destroyed it so there's no longer a transform to tween. So to check if that's the case, we've created a bool method called isTargetDestroyed, and we need a few checks in here. Was they target a mono behavior, a game object, or a delegate? And they are now null. Then we return true, otherwise return false. That should cover most of our bases. Then up here in the update, we can say if target was destroyed, then do a full kill and return. Okay, now one final thing, we need to also remove items from our dictionary when they are complete. They're not mono behaviors, so you can't call destroy or anything like that. The garbage collection process in C# will clean up and get rid of it eventually for you. That's the case with everything that you create with the new keyword, by the way. That's not a Unity specific type. So that just means if we remove it from the dictionary, it will clean itself up. But as I said, we have to be careful when we remove things from a collection while we're iterating through it, because that can cause errors. So what we're going to do is add the link namespace at the top here, because we're going to convert our dictionary to a list here. By doing that, what we're doing is taking a snapshot of the dictionary and converting it to a list while we iterate through it. So we're now iterating through a list copy of the dictionary, making it safe to make changes to the actual original dictionary while we're iterating through it, since it's now just a copy. And let's make a helper method to remove the tween from the dictionary. Also, we only want to do this if the tween is complete and was not killed. Then at the end, remove it from the dictionary. And if the tween was killed, then remove it from the dictionary as well. Okay, now I'll give you a few more examples to hopefully answer a couple of questions that might come up as a result of all of this. So tweening one sprite is all well and good, but maybe you have a character like mine with multiple child objects that make up his whole body. So how do you tween something like that? Well, in that case, going back to our tween manager, let's create an overload method for tween sprite alpha. It's going to work mostly the same, except we'll pass in sprite renderer instead of game object. That's all that's required for overload methods, by the way. Same name, same return type, different parameters. So in my test script, I'll get all his sprite renderers in children and put those in an array. Then I'll call tween sprite alpha inside a for loop. And you can see we have two options for this method now. The first one takes a game object, or the second one, which takes a sprite renderer. So we'll pass in the sprite renderer in the current index, and let's just ping pong it so it doesn't stop so fast. Okay, so that's how you would tween a group of things. Next is maybe you want to keep things a little bit more high level and less specific. So let's set up a method for that as well. So I've added this shader to my player, which just allows me to overlay a color on top of him based on a float. That's perfect for a hit effect, so I want to tween that float from full back to 0. But I don't want to have to set up a whole separate helper method or pass in a string for a parameter for the shader or anything like that. So let's just keep it high level and just make a method that can tween literally any float you pass in. So we'll create a tween float, and what we want to put in is a getter and a setter. For the getter, we'll use a func of type float, and for the setter, we'll use an action of type float. If those are not options for you, by the way, add the using systems namespace at the top. So again, set up the property identifier. We also need to set the target, which will be our getter's target. And we need to grab our start value as well. which will be our get float to tween. Create the new tween, and then return the tween. Now back in my test script, you can see I created an int which grabs the shader property. Caching it like this is literally twice as fast as putting in the string each frame. I've tested it. We also need to grab our materials. Now remember I said we need to pass in a getter and a setter, so we need to create those so we can pass them in. That's the getter. And that's the setter. And they are based on a lerped amount float that I set up. So now we can call the tween float method, pass in the getter and setter, as well as the end value and the duration. I'll set the ping pong to 2 so that it goes to where we want and then back again. But we have to remember all this is doing is lerping this float. It's not currently doing anything to our shader right now. So what we'll do is call the setOnUpdate method and call this onUpdate method, which will loop through all of our materials and change that shader's float to our lerped amount float. So that is an alternate way for you to do things at a little bit more of a high level. And finally, I'll just make sure that you know how to call the pause and resume functions. Again, our tweens return a tween type, so we can just create one and assign it here. And then I'll say if we press P and the tween is paused, then we'll resume, otherwise we'll pause. Sorry, that should be iTween, not tween. And now we can play. I hit P, it pauses, P again, and it resumes. So if you want to take this and run with it, go for it. There's definitely a lot of room for improvement here. I just wanted to get the bare bones stuff set up. In the tween class, just keep in mind that we only have float, vector3, and color in there for the types. So if you want to be able to lerp other things, then you'll need to expand that method. And in your tween manager, you can just go in there and add helper methods whenever you think of them or need them. And eventually you'll just have this really incredible library of helper functions to help you tween things in whatever way you want. Hopefully to ensure that you never again have to use coroutines to just lerp your values ever again. By the way, my patrons get access to the source code for every tutorial ever made on this channel. So if that interests you and you want to support this channel, then go check us out on Patreon. That's all I got. See you next week, guys.